And we're live. Greetings, everyone on YouTube. We're live on X as well, and also on the Trellis research page on LinkedIn. This week, we're going to be talking about dataset preparation. There are two key papers I'll very quickly browse through. The FineWeb paper and then a recent paper from Meta. And after that, I'm going to go through a quick demo of how to do a specific type of filtration of data that will allow you to balance it out. So hi to everyone who's joining. Let me know if you're in the chat. Feel free to drop a question if you like. And I'll see if I can handle some of those as we move through the live stream today. This will be the last live stream until the start of July. I'm going to be traveling for most of June. There's a possibility I'll do an ad hoc live stream, and I'll let you know if you're signed up to the newsletter, which is blog.trellis.com, or if you follow on X, you should be able to check it out there too. Hey Yugi, welcome to the chat. Thanks for saying hi. Let me know if you have any questions. And in the meantime, I'm going to get started. So a few things. I'm doing well, Yugi. Thanks very much. I just got out that video earlier on anonymizing prompts, so taking out sensitive information before you send it over to OpenAI. So I was glad to get that video out. And been facing a bit of camera issues today, so I'm using my laptop camera, which should be okay because mostly you're looking at the screen here. Nice to see some attendance from Warsaw. Hi, Charles. So yeah, two papers that I think are pretty interesting when it comes to thinking about data. And I'll try and make some points here that aren't covered in some of my videos today. The first is around the importance of data filtering, and it comes out really clearly in some work by Hugging Face. You can check it out on the FineWeb repo. In fact, we're going to check it out right now. Of course, many of you probably know that when you are training a language model, possibly 90% of the training is really just dataset preparation. That's probably what allows Mistral to release these models that are almost as strong as OpenAI's, even though they've got probably an order or two of magnitude less funding and spend on GPUs. And that is what differentiates. You can also see it with the Phi 3 model. They're using less data and they're using smaller models. And the Phi 3 mini model is in some ways outperforming Llama 8. So a 3 billion parameter model outperforming an 8 billion, and that's down to data. Greetings, nice to see more Europeans here. Prague, Germany. Thanks for joining, Christian. Lucas, likewise. And Nigeria. Great stuff. So let's dig in here and see about this FineWeb paper. FineWeb is not just a paper, it's actually a data set, a very large data set, and it's used for pre-training language models. This is it right here. So you can see Hugging Face FineWeb. And what I want to do is check out one of the papers. In fact, maybe I'll see the graph. There's one key graph. That's all I need to show really to highlight what FineWeb is about. And it's this graph here. So one way you tell if a training set is good is by training the exact same model on that data set and then training it on some baseline data set, maybe Common Crawl, for example, or some of the well-known data sets like Red Pajama, the Pile, Slim Pajama, C4 is another well-known one. So what you're seeing here is the score as you move through this amount of training tokens, counted in billions of tokens. And FineWeb is the Hugging Face data set they've released. It's an open data set based on Common Crawl. And you can see that the average score of models trained, or of one model in this case, trained on that data set is outperforming all of the other models here. And the question is why? So why is that data set doing well? And we're going to dig into some of those reasons. And yeah, Yugi is right in saying pre-processing seems challenging. So how do we pre-process this data that's on the web? And well, I'm making some videos. I've made a Wikipedia video you can check out that uses Wikipedia data. And I'm hopefully going to get one out in Common Crawl soon. But we're going to touch on some of the ideas of how you process that data. And I know some of you are thinking, oh, well, we're not going to pre-train language models. But I think some of the concepts here are going to be relevant for doing fine tuning. So we're going to see that when we talk about deduplication. We're going to see that in particular when we talk about balancing the data set and making sure that the examples cover a breadth of the use cases, because that is one of the key improvements you can get on performance that we'll see in the meta paper. Okay, so here, FineWeb. FineWeb is basically a common crawl data set, but it's been very heavily filtered. And we're going to take a very quick look at that filtration pipeline. You can head over to Data Trove and check out the fineweb.py link. So let me increase my screen size a bit here. And I'm going to show you, I know this might seem like a lot of code, but it's actually quite a short file. And it's the master file that's used for cleaning up the common crawl data set. Now, just for those, many of you probably know, but common crawl means literally scraping the whole internet. It's a process that's done by, I believe, a non-profit organization that's called Common Crawl. Let's see if we can go to it now, commoncrawl.org. So periodically, this organization will just crawl the web and they will create dumps of this data. The latest one is a May sometime. So this is basically all the data from the internet. And I can say from digging in that it's quite messy. There's a lot of data that is just gobbledygook. It's a lot of extra spaces, a lot of new lines. So it really needs to be cleaned up if you're going to use it in a useful way. And if you look at these data sets here, they're all attempts to clean it up in different ways. And the reason why FineWeb is doing better is because they're using better filtration, essentially, than what's being used in all these methods here. And the reason why filtration is important is because if you just use the raw data, if it's a mess, the language model is going to be much slower to learn from messy data than it is from clean data, where it's able to reduce its loss much faster with fewer numbers of steps. So it's about quality, but it's also about balance. And we'll see that a bit more when we get to the meta paper. But let's just quickly go back and take a look at how the data processing is done in the case of FineWeb. And I won't go through this in too much detail, but I think it's still instructive to see the high-level steps. So first off, here there's work reader. Work files are web archive files. They're the files, file types in which you store common crawl data. So this is simply reading the data from the latest dump. Then here you can see there's a URL filtration step. So this is going to just filter out lots of websites purely based on what's in the URL. You can include blacklists here to get rid of either sites you don't want because of the content or sites that you think are going to be low quality. Then you have this trafilatura. I'm not sure how you pronounce that, but what this does is it extracts the text from what are basically HTML files. So web data is going to have HTML, and you want to make sure you grab the text fields. So this is at a high level what the trafilatura does. Next is language filter. And this is going to filter out pages that are English. So you can actually see the settings here, but if you dig into the code, you'll see that it's set for English in the default. Howdy from America. Welcome to the chat. So yeah, this is filtering out English. I'm making a video to filter out Irish so that I can fine tune a model to be better at Irish. Somebody reached out during the week. They said, oh, that's great, because I'm trying to fine tune one for Arabic. And yeah, you'll be able to do the exact same thing as I'm doing for Irish for any other language. So this language filter, I'll get into it more in the video, but it basically uses a small model to detect the language of each entry, and then it will either filter that in or out of the data set. Now, after this, there are a series of filters, and you can see that, interestingly, FineWeb is borrowing filters from other data sets. So here's a C4 quality filter, and C4 is a fairly well-known data set. You can see it here in blue. It's actually quite a good data set. It's close to the FineWeb. So it's using the C4 quality filter, but then it's adding on some other filters here, like FineWeb quality. And here we have some go for repetition filters. And I'll just mention two of the types of filtration that are used here. One is exact match. So it will do a comparison on a sentence by sentence basis of the data. And if you have entries that are matching closely or exactly, then it's going to filter out one of the copies. Because what you don't want in a data set, and this is true for fine tuning too, you don't really want entries or rows in your data that are exactly the same. It can be good to have some rows that differ, come at the data from different angles, But if you have rows that are exactly matching, that's just like training for another epoch. So it can result in overfitting. Likewise, and we'll see this again in the meta paper, but if you've too much data that's covering, say, let's pick something like, I don't know, history of Ireland or something. If you just have, or maybe a better example is dogs, because dogs is something that appears a lot on the internet. If you have a ton of data that's on that, when your model is being optimized, it's constantly seeing data on dogs and it's trying to improve in that direction. And the more you force it to keep improving in that direction, it's going to start forgetting about the other data. So you don't actually want your data set to have too much concentration in any specific areas. You'd prefer it to be fairly balanced so that it's able to adapt in a little and balanced amount for each type of data that's within it. So yeah, I mentioned already the exact match. There's also a method based on hashing. So you will take a hash, which is putting the raw text, well, the ASCII representation or the bit representation, you put it through a mathematical calculation, and that calculation will have a numerical output. And by attacking it with a few different calculations, you'll be able to get kind of some coded representation of the structure of that text. And now by comparing what is now a more compact mathematical representation of each text, you're able to compare those, and you can determine, okay, if it's on a metric of 0 to 1, if it's very close, we're going to just throw it out. So this is another way of doing deduplication. It's called a hashing based approach. So you have just text match and you have hashing based approaches. And these are all included here within these steps. So I just wanted to show that and also appreciate that Hugging Face has made this open source. So if you were pre-training, you would be able to just download this data set, which is absolutely huge. It's in the tens of terabytes. So something that might be challenging to do, but I think a few lessons that are here in how we want to treat our own data. All right, let me know any questions as we go along. I'm going to chat a little now about this second paper here, which is from Meta, formerly Facebook. And this paper here is on data curation for self-supervised learning. And I don't know, I think the title here, yeah, I guess what they're talking about is pre-training, and that's why they're saying self-supervised. You're not preparing your chat-based information, but yeah, this is really interesting. It's really interesting for pre-training, and it's really interesting for fine-tuning. And here's the point I made about the dogs, right? So here you have the internet worth of data, and tons of the data here on the internet is going to be about dogs, and tons of it is also about websites, like talking about websites, whereas it's got maybe here this toilet plunger, which is going to appear in much lower frequency. And as I said, you don't want to be overemphasizing any one type of data, because the model will just keep updating that direction and slowly forget the rest. What you rather want is you want to have the data more flat. So this is a key insight, and they are able to show that if you train models that are flat versus models where you basically cut off this tail to balance the data and make it flat, you're able to get much better performance. And here, I think this is a comparison where they have a baseline and then they have their approach, which is using the same initial data set. It's just that it's been filtered in order to be flat. So this approach here is pretty useful. Now, the question is, how do you flatten a data set? So if you start off with a data set and you have it in meaningful categories, and some of you might have your data in meaningful categories if you're doing fine tuning. Well, one way you can look at it is maybe you should just try and balance the data that's in the categories. So if you're fine tuning on history, maybe you should have a bit about Ireland, a bit about the UK, a bit about the US. Maybe you should balance it that way. And to some degree, that's a straightforward approach because you have the categories. But of course, when you have just web data from the Common Crawl, it's not obvious exactly how you should categorize it. And furthermore, even if it was obvious how you should categorize the data, it's not necessarily the case that the language model will see the categories the same way as you do. So yeah, sure, for me, like, you know, there's Irish history, there's UK history, there's history from US, Nigeria, whatever. But the language model might actually see that kind of as one category, whereas it might see geography is some other category. So it might have a different way of looking at things. And what's important is the language model's way of looking at things. That's what's important to get balanced. This is kind of just illustrative when I say dogs or website data. What's important is how the language model looks at it. And what we really want to do is balance it from the perspective of the language model. So one of the ways we can do this is by considering the vector embeddings. So in a language model, the first thing you do is convert the tokens or the words into vectors. So every word is represented by a direction and a magnitude in some very high dimensional space, and the direction and magnitude is related to the meaning. So if we create vectors for all of the words or all of the rows in our data sets, we can now average them across those rows and have a vector for each of the data set rows. And using that, we're able to do clustering. And I'm going to show that in the notebook. This is basically what's happening here. We're doing some clustering effectively based on the embeddings of all of this data. And what we're doing is removing some data from the big clusters, from the clusters that have lots of information. So let me go back here and here's a cluster drawing I made a little bit earlier. And you can see, I'll describe exactly how I get to this, but basically this is a data set. In fact, why don't I just tell you what data set this is, because I have it loaded up. And somebody by now should have asked for this notebook, which I can share. Let me copy the link and throw it into the chat here. And I have shared it so anybody can access. So let's try and make this a little more concrete. I've installed the datasets package. And what I want to do is I want to take a data set. I'm actually going to take this data set I've created. It's an Open Assistant data set that you'll remember if you were here on the call last week. And what it is about 10,000 rows of data that come from the Open Assist database. It's a specific project that was run to collect user data in conversational format that could be used for chat fine-tuning. Tim Detmers then did a filtering of the best examples, and I further filtered it here to be in the style of Llama 2. So you can see these inst and end instruction little strings here that denominate start of the discussions. So this is a data set that people will often use. I'm not saying it's the best data set, but people will use it for fine-tuning when they want chat performance. Like if you start with a base tiny llama model, you can use this. And if you look at my chat fine-tuning video on YouTube, you can see how this is used to get a chat-based model out of the base. And what I want to do is I want to just inspect this data set and show you how we can kind of flatten it out and make it more even amongst all of the different meanings that are within it. So I'm going to use this data set. I'm going to load it up here. Here's the data set. And I think I'm going to load the model. Let's see where my load model is. Load data set, it's right here. So you can see I'm loading the train and the eval split. And we're actually only going to use the training split. So I only need to load that. And then we're going to inspect it. Let me just take a question here. So Loic is asking, but if you use the mean to create the embedding of the chunks, after filtration, you can lose bijection. Yeah, I think there's some drawbacks to using the mean. We're just going to apply an embedding model, across all of the sentence. So I'm not explicitly taking a mean, but it's being handled within the model that we're going to use for embeddings. So yeah, let me just describe a bit to give context on that comment. So what I'm doing is I'm taking my data set, and my question is, can I divide these rows? Can I group the vector representations of these rows? That's what I want to do. Each row here, I'm going to convert into a vector, and I want to group them so that all these rows are kind of grouped in a way that's meaningful for the language model. And the way I'm going to do that is using an embedding model. Now, you could argue a good way to do this would actually be to use the first layer of the language model that I ultimately want to do training on. But of course, if you're training a model from scratch, you don't have that model trained yet. So you'll have to decide some way to create the vector representations. And the model I'm going to use for that is an MS Marco model. you can see, I think I use this model if you go back to my video on retrieval augmented generation. So this is the model. It's not a very big model, and I'm going to use it to create vectors, which are also called embeddings. So here I'm going to take the text within the training data set, and I'm going to encode that into embeddings. So that just means I'm converting each row into a vector. And then what I'm going to do is I'm going to take these embeddings and I'm going to cluster them. And I'm going to decide that I want 5 clusters. That's, my choice, somewhat arbitrary, but I'm going to cluster it, and I'm going to cluster them so that we try and minimize, basically develop clusters where the center or the centroid of each cluster, the distance from the centroid to those points is going to be minimized across all the clusters. That's what we're doing. And when we do that, they will be in clusters, but they will be in clusters in this very high dimensional space. I don't know what the embedding dimension is of this MS Marco model is. I think it's 512. So they're going to be in clusters. It's hard to imagine, but in some 512 dimensional space. Now, of course, I can't visualize a 512 dimensional space. So what I'm going to do is project that. I don't know why I'm putting my hands in the air because this isn't even possible, but I'm going to project the clusters in 512 dimensional space onto 2-dimensional space so that we can see it in a graph. And it's going to be this graph here. And the way that works is basically you have to also solve an optimization problem that will create clusters where the average distance in 2D is somewhat similar to what the average distance is in 502-dimensional space. So that's me just explaining how you actually visualize in 2D. You have to solve an optimization problem, which is solved using this TNSE method, which is here, the TSNE method. That's how we basically visualize the high dimensional space in 2D. That's purely a visualization step. The clustering all happens in high dimensional space. So here, normalize the embeddings to fall on a unit sphere. Is there an opportunity to normalize? There might be. It might be worth looking at that. And since we're using cosine similarity, and yeah, I guess when we're doing the k-means here, we're not explicitly doing cosine or dot product per se. We're looking at the distances between them, which I guess is more of a dot product, I think. But we're not doing kind of RAG here. And like here, after filtering, you can drop, for example, 5 plus 2 equals 7. It's only 2 plus 5 equals 7, so we'll be using fine tuning. Pi plus 2. Yeah, I need to think more about that. I need to think more about what you're getting at there. But for now, hopefully suffice to say that we have found a way of grouping these rows. We found a way of grouping these 10,000 rows into 5 groups specifically, because I've said 5 groups. And this is basically what they look like in raw form. So this is kind of what the data looks like. So I'm just at the starting point. I haven't done any of our method yet. This isn't the method of how we filter it. This is just how do we visualize roughly what this data looks like. And second of all, it's to highlight that within this data set, even this data set with just about 10,000 images, 10,000 rows, you can see that the clusters are not all equal. So this green cluster, for example, has got quite few points, and this purple cluster, whereas these 2 clusters here, red and blue, are absolutely huge. So there is imbalance in the data set, and we could balance it by picking a fixed number, let's say 100. We could pick 100 points from this and 100 points from the orange and the purple and the green and the blue. And what that would do is basically start to balance our data set. And that's the idea of the sampling we want to do. That's what they do in the Facebook paper, and they do it recursively. So they will run the clustering, they will sample an equal amount, and then they'll rerun the clustering on that data set. So actually, I'm going to show the code for how that works. So what we're going to do is we're going to set up some code to select samples per cluster. So this is where we're setting a fixed number of samples, and it's going to be a maximum number because we can't, if we say 100 per cluster and there's only 50, we're just going to have to take those 50. So there's a max number of samples per cluster, a number of clusters, and then the input data. So this is our function to select samples per cluster. And once we select that, we want to visualize it again. And to visualize it again, we have to solve that optimization problem to visualize the high dimensional space in 2D so we can see it. So I've just, again, somewhat arbitrarily selected a max number of samples per cluster of 50. And yeah, you probably should play around with these values and see what would work well. And then basically run cluster and visualize. And here you can see, I think actually this is after running it quite a few times, but I've clustered it. And what you see now is you have 1, 2, 3, 4, 5, still 5 groups because I set it as 5, but it's much more balanced in terms of the data that you have. So effectively what I've achieved here is starting off with the data being quite unbalanced like this. I've now clustered it and I've managed to get my data to be more balanced. Now, of course, you're going to realize that there's just way less data here. So to some extent, you could say 50 is going to be too low of a number, and I want to be able to retain more data. So I should probably use a higher value than 50 for my cluster size so that I'm not just tossing out all of that data. But there is going to be some optimal value where it's just thinning out some of those fatter groups that we see up here. So then you can run this step again. And basically, once you have filtered out down to this, what you're doing by reclustering is the clusters won't necessarily be the same if I just analyze these data points from scratch again, because it's going to recalculate what makes the most sense as clusters. So you run the process, you cluster, you visualize, then you recluster, and then you revisualize. So this is a representation where I've just basically rerun those steps of clustering and visualizing again. And ideally at each step, you bring the model more, you bring the data set more towards being balanced so that it's got clusters that are disparate, but roughly balanced in terms of the data quantity that's in them. Any questions on this? Just feel to drop them in the chat and we can talk about it more. I will say that if you're doing fine tuning, in a lot of cases, at least where people reach out to me or ask on YouTube videos, data sets, they tend to be kind of focused. Like you're fine tuning on touch rugby, you're fine tuning on maybe, I don't know, something about the science of astronomy. Maybe the concepts there are not so disparate. And so maybe thinning it down. Furthermore, if you're dealing with smaller data sets, 10,000 versus fine web, where you've got trillions of tokens, you've got less room to thin down on your samples as well. But I will say you can always think about when you're fine tuning, you can think about using synthetic data to expand the data where you think it might be light. And then you can think about this kind of filtering to balance it out. So by combining those techniques of thinning your data out, but also expanding it where it's needed using synthetic prompts, I think you can kind of get a good balance. Question from Saman, is it true that the magnitude of an embedding is influenced by the length of the text, whereas the angle encodes the semantic meaning? So the length is to do with the quantity of information, whereas the angle is to do with the type. So for example, this is oversimplifying, but in a paragraph, if you have a lot of tractors, like tractor is going to be this direction, let's say this direction upwards. But if you have a lot of tractors, it's going to be a long vector in that direction. Whereas if you have maybe beautiful, like the concept beautiful, like beautiful is maybe this direction. But if it's just kind of barely mentioned, it's only going to be a small magnitude in that direction. So that's kind of the way to think about it. The length is the quantity of that specific meaning. Okay. So I do want to show you one little demo of how I generate some synthetic data using ChatGPT. Of course, you can automate this by API. And if you check out one of the earlier videos on dataset generation, you'll see that I do it using RunPod and TGI. You could also use VLLM. But the specific recommendation I have is when you are using SFT trainer, which many of you are, and this includes if you're using Unsloth. Let's just see if we can go to the Hugging Face documentation. When you're using SFT trainer, there's this nice shortcut whereby you can pass in data in messages format. So let's see here. Here you can see the data set is being passed in, and often you will then say, okay, I want to grab the text field. So if I'm training, one approach is you just prepare and pre-format. The prompts are all ready and you have everything pre-formatted and you just put that in a text column. That's one way to go. And that way works if you want to do unsupervised fine-tuning. Technically, you can use it with supervised as well if you turn on for completions. But just for now, yes, this is one way you can do it with the text field. But this is a little bit annoying because it means that you have to have pre-formatted your data. And if you change your chat template, this data set is not going to work. So for example, this data set is not going to work if you want to fine tune in the style of Llama 3. The prompt format is clearly wrong. It's also wrong if you want an open assist type prompt format. So you'll have to recreate your data set every time if you're using this text field because the chat template is pre-applied. And actually that's why I even created this data set, because if you go to Tim Detmer's Open Assist, you're able to see here, Open Assist Guanaco, you're able to see that he has the Guanaco style, which is starting with human and then using assistant. So this approach is fine, but it means you have to pre-format your data set. The other approach with supervised fine-tuning trainer is you can not even specify this here. And instead you can set up a data set where the column here is called messages. And instead of the text just being a string, it's set up like messages. And I want to show you just how you would do that in terms of prompting a language model. And I'm going to do that just for a sample Wikipedia page. So let's go to a random Wikipedia page here. Kolkata Night Riders, nice. Something to do with cricket. And let's just grab what's here. We don't need that much. Let's go as far as home ground. I know I'm not cleanly copy pasting, but that's fine. Okay, and let's say we want to create a data set to fine tune on this, and we want it to be supervised fine tuning, and we want it to be question answer format. So what I'm going to do is help me to prepare some data. Let's say a data set. I want to generate, let's say 5 questions and answers on grounded in the text above. Text. And by the way, it can help if you just wrap it like this. So I usually do try to wrap whatever input text I put in. So it's just in some wrapping symbols here, some wrapping tags. Got input and here. So let's ask for 5 questions, and please respond only with the questions in the following format. And will we do 5? Yeah, we'll do 5. So each one needs to be an array of messages. And the only way we can do it if we're going to pass in a messages field to the supervised fine tuner, which when I say pass, you actually don't have to pass it. It will automatically detect if there's a messages column within your data set. And you'll be familiar with this when you see it. It's role, and then user, and then you have content, and then you have the user's question. And then here you'll have the assistant version of that, which I'll just paste and make sure my syntax is correct. Here the role would be assistant, and here it would be the assistant's answer. So let's see now if it responds. We may need to adjust our prompt it's not doing exactly what I would like. Okay, so it's not exactly what I'd write. Like, each set of messages should be its own array. I need to make sure each set of messages is, yeah, so here we go. It's an array of arrays. And within the given set of messages, you have this. So yeah, you can see that a strong model like ChatGPT or GPT-4 or Opus, they're going to just one-shot this, and they will, with the proper prompt, they will just give you the correct answer. If you want to be fully sure, you can turn on JSON mode when you're calling OpenAI. You can also do that with an open source LLM. If you want to be fully sure on the commercial licensing, you could use, say, a Mistral model, and you can use VLLM with structured generation. Check out, there's a video I made called All Sort where I talk about structured generation, but that will guarantee that you get the specific structure that you want. And with this now, you're able to upload this to Hugging Face, and you'll have it in a single column that's called messages. And the beauty there is that when you pass that into SFT Trainer, it's actually going to apply the chat template automatically that's associated with the tokenizer. So do make sure your tokenizer has got the correct chat template set. We can maybe see, yeah, you see this is the format I'm talking of, the conversational style. And it's this part here that you want to make sure is uploaded as a row. And if you do that, yeah, you can just pass in the data set, but you don't need to pass in the text field. It'll just, you don't need to pass in this. It'll automatically detect that there's a messages column within it. And I think this is the fastest way to basically create a data set that has rows of messages, and then you pass those messages into the SFT trainer. And you'll see this, anyone that has access to the advanced fine-tuning repo, this is the approach I pretty much take all of the time now if I want to fine-tune. Okay, great. I think I've covered the key points I want to, so let's focus on a few questions for the rest. Charles, I've requests from a customer service chatbot. I filtered out distinct chats and a human has labeled it. Okay, this sounds like high quality data. Fine-tuning this for text classification, do I still need to normalize? So let me just address the first part. If you filtered out distinct chats, these are going to be, you want to format them ideally, and you can have ChatGPT help you reformat them. You want to format them just like I showed here. So you want them to be formatted as messages with a user content and then role assistant content. And by the way, you're not just going to have user assistant, you're probably going to have user assistant multiple times if you've got the full chat. And when you say you've labeled it, I assume what you mean is that, well, one of two things. One is either somebody has chosen which roles are good quality and you want to use for training, or you might also be saying that they have manually adjusted some of the responses to be better, which is, that could be really nice. So yeah, if you have that kind of data, that's perfect then for doing supervised fine tuning. I just want to say something about preference fine tuning too, but first you're saying fine tuning this for text classification. So I wonder, are you really asking about text classification? Like you're not trying to train a llama model? Maybe you're trying to train a BERT model for some other purpose? When you said the first two sentences, I would guess you have applied context. Okay, I'm not quite sure what applying context means, but yeah, if you're fine tuning for classification, I'm not really sure where normalization would come in, but hopefully what I described will help you just understand around the format you want to get it in for doing that. And by the way, you can check out the video I have on memorization. I think I do prepare the data like that in that video. Question on the tokenizer, not having a chat template. Okay, what do you want to do? So the easiest thing is to grab one from a model that does have one. So let's go to the Llama 3 model and see. Always, usually the instruct is the one that has a chat template. The base model doesn't. And go to tokenizer config. I'm probably blocking here what you want to see. Okay. So yeah, go to files, tokenizer config, and you see down here, there's so many added tokens in Llama 3. But here's the chat template. You see it? And here it is. So basically you just copy that like this. And let me just create, let me create a new section. What you would do, let's assume you had a tokenizer. This style won't work, but if you have a tokenizer that's loaded, you would just do tokenizer chat template and then set it equal to this. You see that? So literally I've just set the chat template to this. And when you run that cell, which won't make sense if I run it because tokenizer is not defined, but if you just have imported the base tokenizer and then you run this, it will reset the chat template to this. Yeah. Oh yeah, thanks. So in the case of Charles here, this is the best case scenario of what you could have data-wise. It's like some real chat data, which means that the questions are realistic. Because one problem with synthetic data is it can be hard to generate questions that are actually representative of what the customers ask. So this is beautiful. You've got real questions. And then if they're annotated, you've got high quality answers. And that's good because you can use the high quality ones for supervised fine tuning, but you can also use both the annotated better ones combined with the original bad assistant responses. You can use those to do ORPO. So to do odds ratio preference optimization. And that preference optimization, it's going to pull the model towards Charles' annotated examples, which are better, and move the model away from giving answers that are like the original ones. So yeah, that's pretty beneficial. And you can check out, there's a video, I think it's even called ORPO or something, where you should be able to, let's see if we can find, I've made a playlist, by the way, for each category. So there's a playlist now for inference, like the video today on redacting private info is in that one. But the one we're interested in is the fine tuning. And if you scroll down, let's see, there's a few that I mentioned here today. So here, prepare fine tuning data sets. This is the video where I describe how to prepare Q&A. And ORPO, combined preference and supervised fine tuning. So yeah, this is what you would be able to do, Charles, if you do have that annotated versus original data. You can, at two for one, you can do the supervised fine tuning like at the same time as the preference fine tuning with ORPO. So yeah, that's relevant there. And yeah, if you want to go all the way back to understand a bit more about embeddings and cosine and dot product, then this part 1 on embeddings. It's 8 months ago now, hard to believe, but yeah, this is the video to look for there. Okay, human agent labeled each chat. State and request. Oh, I see. So you've actually further labeled what each chat relates to. Okay. Yeah. Well, that's good because it allows you to inspect in the data set the balance, and you can check that you're covering enough of your use cases. I think what you want to do as well is figure out a way, either automated or manual, of deciding what the weak areas are. So are you really bad at balance check? If like your model is really bad at balance check, but it's good on statement request, that can inform where you need to spend your time and what kind of examples to include in your data set. And for example, if you're bad on balance check and there's not many samples, that's a perfect opportunity to try and create some synthetic ones. Can SFT support any chat template based messages data for training? Doesn't it use chat template internally to adapt the structure? Yeah, so SFT, if you pass in a messages column, you must provide it. You must provide the data in this format here. It must be in an array of these curly bracket wrapped role and content keys and values. So you have to provide the data in this way. It's not going to accept it any other way. And what it does internally then is, I'll show you what it does internally actually. It basically will do this. It will do messages equals grab a row from the data set. Okay, I'm just saying what it does. And then it will do tokenizer, apply chat template do the messages like this. So that's what it will do. Yeah. And in that way, it's basically applying whatever chat template you have defined. So this is kind of what's happening behind the scenes within the SFT trainer. It's running tokenizer apply chat template on whatever the defined chat template is. So hopefully that answers the question there. Saman's asking, I heard of some research suggesting that fine-tuning on novel data will increase the rate of hallucinations. What do you think? Yeah, I suppose novel in what way? Like if it's novel and it's not related to your use case, yeah, that sounds bad. It sounds like it's not generally bad, but if it's a small amount of data you're fine tuning on and you introduce some novel data point, it's just going to result in a spike in the loss during training. So it's just kind of like whacking your model with a hammer if you put in a piece of data that's completely unexpected. So yeah, I mean, I'm not saying you would do that. I don't think you would just go ahead and put in a novel piece of data that's outside your data set. But yeah, I could certainly see that increasing hallucinations. If it's novel within your data set, well, that might just be important. Like the model might not be performing well on something that's novel, but that novelty might actually be what you need to capture. So then I think you're just going to have to make sure you have enough data points that properly capture what that novelty is, and then, you know, use the appropriate learning rates so that you're not too quickly trying to adapt the model to it. But yeah, hopefully gives you a bit of a sense. If the tokenizer doesn't have a chat template, yeah, it will raise error. It'll tell you to either specify a text field and provide some information. I don't have the data set up anymore, but it'll tell you to specify what the text data set field is. And what it's really saying is, oh, I don't see a messages column in your data, so you should be specifying what column you want me to look at. And if you're specifying the column, then I'm not going to apply the chat template automatically, because when you specify a column, I just put in the raw data. I don't chat template it. I only chat template it if it's a messages column in the input data. And sorry, I repeated that. New language. Let's see what you're saying here. Saman, you heard of some research. Okay. Not commonly encountered in pre-training. Tell me more what you mean here, not commonly encountered in pre-training. Yeah, I see what you're saying. Yeah, like if you suddenly come in with a new language, you're just going to see a spike. So you can actually see this when you, like I've done it before, or I'm training for function calling and I've just made a mistake. Like my data is not formatted properly, and one of the rows or many of the rows are just junk. And what you see when the trainer gets to that row is that the loss just like spikes. And sometimes that might even cause the training to crash because the gradients become unstable. So it's the same thing. If it sees any type of data that is radically different, you're just going to see a spike in the loss. And yeah, like this is actually why when you're training, and it matters more on longer fine tunings, but you have this thing called warm up. Warm up is where if you want to train at a learning rate like this, you actually don't immediately start with that learning rate. You warm the model up, so you slowly increase the learning rate. And what that does is, if the model does hit data it hasn't seen, it's not going to have as much of a spike because your learning rate is small. So you're kind of slowly moving the optimal point rather than like jolting it with a hammer. So yeah. Okay, folks. Just before we leave, let me ask you, any thoughts you want to share on what you might like to see in future videos? Feel free to drop a comment there now. As I said at the start of the stream, unfortunately, I won't be streaming in June as I'm going to be traveling. There may be a surprise stream there somewhere, depending on how my schedule works. But hopefully I'll be back in July again. I will be getting out some videos in June though. Yeah, text classification. I think with classification, I mean, a lot of the same things apply, Charles, but you'll be using maybe a different model like BERT. So yeah, your classification, if you're doing classification, then your labels matter, because your objective is going to be those labels. So it's not going to be relevant what we're talking about here on the chat templating. Okay, Saman wants to see some more on unsupervised. Great, I'm glad, because I'm going to be, the next video hopefully will be on Common Crawl, and that's going to be more unsupervised. Saman, did you see the Wikipedia video, by the way? I'm curious if you saw that. Yeah. Do you need to, can you set your own base model? Yeah, you can. You can just arbitrarily set your own approach, but there are some approaches that work empirically better than others. So you probably don't want to go crazy. You probably want to stick with one that is used by one of the main models. And no, if you're just putting the strings like user or assistant, they're not tokens. You're just setting the strings. And actually, that's the same thing as here, or rather, if I go back to, let me just go back to my data set where I have the open assist. When I have the inst and when I have the end inst, and trellis open assistant, you see here, like inst, this is not a token. This is just a string. Can you see my screen? No, because I'm blocking you. Yeah, inst is just it's just a string, so it's not token. So they're separate ideas. Like you can just do it with strings, and it probably will work. Like OpenAssist Guanaco works. This also works. But the tokens can be effective in giving structure, and that's probably why most language models have moved towards a chat-ML type structure, where they do specifically end and start with tokens that are defined in the tokenizer. So yeah, maybe you just want to copy the Llama 3 tokenizer. I guess the follow-on point though, which you're kind of raising that's important, is not only do you have to set that chat template, but you do have to set, you do have to define those special tokens in the tokenizer. So I'll just write it here in text, but you'll have to define the tokens in the tokenizer using tokenizer add special tokens. You'll have to make sure as well that they're recognized, that they're recognized in the model. So this actually does involve quite a few steps. If you check any of the videos, like even on Orpo or on chat fine tuning, you'll see that I do talk about it specifically in those videos. Yeah, and furthermore, you probably do need to train the embeddings. So you probably need to train embed tokens. Yeah, so that's if you're doing LoRa. And you'll see that mentioned in the chat fine tuning video on Orpo as well. But yeah, basically, if you do define tokens for your chat template, then you need to make sure that they're included in the tokenizer and that the model expects them to. So yeah. I think that was this question. Images, tables, and data sets. Yeah, I mean, ideally, like, I don't know about ideally, but if you're doing a text model, you obviously can't include the images. Maybe what you could do with a fancy data processing pipeline is you could replace the images with a text description of those images, maybe using some external image description tool. I don't know. I mean, that, like, it's doable, but that's kind of a lot of work. But ideally, you want to retain the full context, because it's unsupervised training. If you're using a raw data set, and just leaving pieces out is definitely going to reduce performance. And that's probably one of the reasons why raw Common Crawl isn't so great. Yeah, thanks, Christian. Appreciate it. Yeah, Irish Wiki dataset, an English Orpo DPO mix was added. Yeah. Yeah, so that's right. In the Wikipedia video, when I fine tune on the Irish dataset, I mix in a certain amount of English data that includes like coding data. This is actually important for reducing catastrophic forgetting as well, because what it does is the model is chilling there, and it's, you know, it's thinking all the usual things. It's thinking, you know, a bit of coding, a bit of English, a bit of Wikipedia, a bit of Common Crawl, a bit of coding, a bit of English, a bit of Wikipedia, a bit of Common Crawl. If you now hit it with a data set that's just thinking Irish, 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 it starts to forget all the other stuff. But if you include a tiny amount, and now it's like Irish, 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 Common Crawl, Irish, Irish, Irish coding, it's like being reminded kind of and probably actually within a batch of 32, because I've put in a 5% mix. In every batch of 32, there's a tiny piece of data that's from the original data. So it's kind of keeping the model grounded to remember, okay, I can't overfit just for Irish because I have to, minimize the loss for this row that is from star coder. So that's the logic of why you want to mix in. Now, does it cause a spike in loss? So the spike in loss is caused by the new data that it's not familiar with. So if anything, the spike in loss is caused by my 31 out of 32 rows that are Irish. That's what's going to cause the spike. But yeah, you address that through like a warm up. So hopefully that helps. Okay. Yeah, something like BERT. Something like that. T5, maybe you can look at T5 as well. I don't know. Yeah, I haven't done a lot of work, Charles, on the classification. You have to look around a bit on the models and what would be the best starting point there. And yeah, I mean, technically you can take any model, like even a llama model, and you can convert it into a classifier by swapping out the language model head so that it will just predict like a number or something else. But that's kind of custom. You don't want to do custom. You want to start with a model that's defined. It'll just make the tooling easier. You can use the tooling from Hugging Face. In Llama 3, the flags are added as special tokens. Yes. So yeah, if you download the Llama 3, like the tokenizer and model are set up with those special tokens. I'm just saying, if you now want to use that chat template on another model where those tokens aren't defined, you will have to make sure that you do define them. So that's kind of what I'm trying to say here. Yeah, tables from PDFs. I think that's good. Or even like CSV files. I think that's good. Like when you process a PDF, I've always just extracted the text, but yeah, it would be cool to extract multimodal maybe, or yeah, not even multimodal tables. I think that's a good idea. Like, yeah. Synthesizer generator step of RAG pipeline. Synthesizer generator step for 7.8b. Synthesizer generator. What's a synthesizer generator? You mean preparing the vector database, maybe? Okay, great. OG Lee, yeah. Love to hear it. Multi-U training. Yeah, so that would be cool. I think multi-GPU could be reasonable. Yeah. I guess there's my video that I did on using FSDP, fully sharded data parallel, and you can kind of use that video too if you want to do deep speed. But it's true that there are many more platforms that I probably could go through. I see, synthesizer. Yeah, that's interesting. I think I see what you're saying. You're basically saying, okay, I've got a RAG pipeline. What's the best way to use that information? Yeah, that's not a bad suggestion. LLM to VEC. Is that the one? Did you mention that, Loic, maybe a week or 2 weeks ago? There is a method for converting an LLM into an embedding model. Is that what you're talking about? Because I did read that afterwards. Yeah, okay. Yeah, okay, so I read it. Maybe you won't like what I'm going to say, but I thought it was really, really complicated to get like an embedding model, and the performance actually wasn't that good. So, I mean, it's kind of cool, but I just think, yeah, it's a really complicated way to get an embedding model. And I'm not really sure there's that much benefit just because it's aligned to the model. I think a lot of the embedding models are pretty strong. Like for a long time, Anthropic was just like, we're not going to do an embedding model. You can just use the best open source one because it's probably fine. I don't know. That might be a bit harsh though. Maybe there's a specific reason to do it, like RAG on steroids. Yeah. Anything on steroids. All right, folks, that's it for this week. Appreciate you all joining. You can still let me know any comments if there are any after the call ends, and it'll be up live on YouTube. And yeah, if you're interested, check out the video on anonymizing data inputs to language models. It just came out earlier today. Other than that, I'll see you all in July for the live stream. Cheers.